This assessment asks us to comment on products A and B from a previous assessment. Just as a reminder as what was done there, we took some alkene, added MCPBA and H3O+, to make a diol where the two hydroxyl groups end up on the opposite side, as drawn. In this case, we could have formed the epoxide on the front and had the water attack from the back, or formed the epoxide on the back and had the water attack from the front. And so these two molecules in A are enantiomers. When we took that same alkene, and what the alkene doesn't matter much for this problem, but that same alkene, when we used OSO4, we added both hydroxyl groups to the same side. So we could either add them to the front, as in here, or add them both to the back, as in here. That happens in both cases. We get a racemic mixture. These are also enantiomers. But what's the relationship between these? And we could do this a couple of ways. We could figure out R and S. We could figure out up and down. Let's do that. Here at this carbon, both of these hydroxyl groups are on bold wedges. So the absolute configuration, if we figured it out, would be the same for these. But for these two, they're different. Okay, that means that these molecules are stereoisomers. They're not enantiomers. If we tried to superimpose these two on each other, we wouldn't be able to do that. These are diastereomers. Let's do the same thing with this one and this one. Notice that now at this carbon, the hydroxyl group is on a bold wedge. The methyl is dashed in both cases, so the absolute configuration of these carbons are the same. But over here, this one is on a dashed wedge, this one is on a bold wedge. These are different. Once again, they are stereoisomers that are not superimposable mirror images. These molecules are diastereomers. Come down here more quickly. Dashed hydroxyl, bold wedged hydroxyl. These are diastereomers. And as you might expect, the trend continues. Dashed hydroxyl, those are the same. Bold wedged hydroxyl, dashed hydroxyl, these are different, also diastereomers. So the relationship between the two enantiomeric products of reaction A and reaction B are all diastereomers of each other.